Good morning, or good afternoon, or good evening, however this finds you. Just real quickly, we're going to have a whole lesson on the periodic table, but I want to show you two things. You have a periodic table image here at the top for continued reference, and I've also placed one in today's lesson, or day 3's lesson, Notes Modern Periodic Table right here. You should be able to save that. You'll see all kinds of periodic tables. They should all resemble each other to most parts, but I want to go ahead and go over this one and show you what's on it and how I would like you to spend some time. Okay, so notice each square. Now this you should have got from videos or the reading, and if not, well, you have it here now. But every element has a symbol. That symbol is generally the capitalized letter, first letter of the name, like hydrogen, capital H. But clearly there's probably going to be some other ones that start with the letter H, and so we'll use the second letter and it'll be lowercase. So for instance, helium. It all starts with an H, but we go ahead and say he. Do the H-E in lowercase. All right. Oxygen, O. There's no others. All others that start with an O, like Oxygen, has O-G. Okay, so that's the symbol. Not all periodic tables have the name. This one does because it's a good teaching periodic table. So it helps you to get to know the symbol and the name together. Beryllium, lithium, boron, carbon, nitrogen, so forth. You'll notice the sequence that they're in, as you've seen. 1 goes across, 2, 3, 4, 5, 6, 7, 8, 9, so forth. What that is the atomic number. Sometimes they'll put it down here or somewhere else. This is, I think, the most common, and should be, because the periodic table is organized according to the number of protons in the nucleus. Remember, protons define that element. So lithium is 3. What does that tell us? That's right, it has 3 protons. And we also know from previous notes, if it has 3 as an atomic number of protons, then it should have a corresponding negative charge for every positive charge, meaning it also has 3 electrons. Look at magnesium, atomic number 12. Remember, atomic number is that number up here. So if it has 12 protons, it means it probably also has 12 electrons, and that's true. Then you have the name and the atomic mass. What was the atomic mass? Do you remember? Correct. Right. With the number of protons and neutrons. Now, we don't need to list the neutrons here and crowd this up anymore. If we know the atomic mass, we know that's both the protons and neutrons. Now, we define the element by the number of protons, so that number is for sure going to be there. And we also like to know the mass, because that has a bearing on how it interacts. Those neutrons are not very influential in any chemical reactions because they have no charge. They simply stabilize the nucleus. So if you want to know the neutrons, you take the atomic mass, in this case 24, you subtract the proton number 12, and whatever is the remainder is what you have for neutrons, because only protons and neutrons have a mass. All right, so that just kind of reviews what you're looking at here in each of these boxes. It tells you the number of protons and the number of electrons, and you can figure out the number of neutrons by looking at the atomic mass, or the mass number, as it's referred to. I want you to notice the ones that are going to be most important to us as we go through the groups are the A's. Okay, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. In class, I just refer to them as group 1, 2, skip a few, 3, 4, 5, 6, 7, 8. That's real important later on. All right, mostly because we don't deal too much with this in basic chemistry and in biological chemistry, which is frankly what I specialize in. We're never too interested ever except for the first 25 elements, and at that primarily up to calcium, and that's up here. 1, jump across 2, jump back across 3, 4, 5, 6, 7, so forth. For this class, you do want to know that this blue line is a semi-metal. Okay, it has metallic properties as well as non-metallic properties. Those are really interesting right here. Everything to the right of that, okay, are non-metals. Everything to the left over here, the largest group, are metals and metalloids. So look at this key down here. You don't need to know, let's see, all these, but you do want to know most of them. We call these also transitional metals. So yep, so we have the alkali, the alkaline earth, transitional metals, then you have basic metals, aluminum, gallium, indium, tin, semi-metal, and then you go to non-metal, halogens, and the noble gases. These are noble gases because they do not intersect. I don't care about these two, but I guess if we're learning all these others, you might as well learn those two as well. But the biggest you want to know is all these over here are metals, all these over here are non-metals, and we'll continue to refer to that general category as we continue learning about the periodic table. Lastly, you also want to keep in mind this does not have listed the rows, but you can count those. 1, 2, 3, 4, 5, 6, 7. This is important because we know a lot about these elements, as we'll see in the future, just based on its position in the periodic table. Not only does this number tell us the number of protons, but its position here is due because aluminum, for instance, number 13, shares something in common with boron, gallium, and indium in that group, but it also shares something else in common with row 3, sodium, magnesium, silicon, phosphorus, and sulfur. So aluminum is perfectly placed right here for the two traits that define it best. Isn't that pretty cool? So we'll continue to unveil that in today's lesson, as well as in the lecture and the readings. All right, that's all for this quick introduction to the periodic table.